Welcome back to The Explainer. Today, we're diving straight into the absolute hero of modern industrial automation. It's a device that silently works behind the scenes in almost every major industry, preventing mechanical disasters and literally saving enough electricity globally to power entire small countries. We're talking about the variable frequency drive, or VFD.
So have you ever actually wondered how massive industries control the speed of these colossal motors while somehow saving a ton of electricity at the same time? It's kind of wild when you think about it. I mean, factories and water treatment plants demand an unbelievable amount of power. But, they don't just plug these massive machines directly into the wall and cross their fingers. There's a genius piece of technology bridging that gap.
Okay, let's dive into this. Here's our roadmap for today. We're going to cover 1. The industrial motor problem. 2. What a VFD actually is. 3. How a VFD works. 4. The applications and big benefits. 5. Crucial safety and troubleshooting tips. And finally, number 6. The future of automation.
Right. Let's kick things off with Section 1, the industrial motor problem. And this brilliantly illustrates why we even need this tech in the first place. The old way of starting a motor, honestly, it's brutal. When you fire up a massive industrial motor directly across the line, it pulls a huge starting current. It's exactly like a water hammer in the plumbing system. You know that violent shock wave that can literally burst pipes? Yeah, it's incredibly expensive and super destructive over time. But switch over to VFD control, and suddenly you get this beautifully soft, precise start, giving you massive energy savings and far less wear and tear on the mechanics.
Which brings us perfectly to Section 2. What is a VFD?
So what actually is it? Basically, a variable frequency drive, or VFD, is a vital electronic buffer in industrial automation. It sits right between the main power supply and an AC motor. Its whole job is to dictate exactly how much energy that motor receives. By doing that, it reduces mechanical stress, gets rid of that violent starting current we just talked about, and dramatically cuts down on wasted electricity.
All right, let's look under the hood in Section 3, how a VFD works.
It's essentially a 4-step journey, taking power from AC to DC and back again. Step 1, your standard AC supply enters the rectifier, which converts it into raw DC power. Step 2, the DC bus and capacitor step in. Think of them like a giant sponge. They filter and smooth out all those messy electrical ripples. Step 3 is the inverter. This is where highly advanced switches, called IGBTs, rapidly chop that smooth DC power back into a brand new AC waveform. And finally, step 4, this newly synthesized variable power is sent directly to the motor.
Now, you might be wondering, how does that actually change the speed? Well, since a motor's physical build, like its number of poles, is fixed, the only way to change its speed is to alter the electrical frequency it receives. It's exactly like turning a water valve. If you crank a valve wide open, water rushes out at max speed, but slowly close it down and the flow perfectly matches whatever you need in that moment. A VFD does exactly this with electricity. It adjusts the frequency to give you perfectly smooth control over how fast that motor spins.
To pull this off, a VFD packs some serious hardware into one box. You've got the rectifier and DC bus, those filtering capacitors, the inverter with its IGBT modules, plus the control board and keypad display. Oh, and here's a crucial detail. Because chopping high voltages generates a crazy amount of heat, robust cooling fans and communication ports are absolutely essential. Literally, without the fans, the whole thing would just melt down.
Okay, let's zoom back out to the real world for Section 4, applications and big benefits.
Just imagine the sheer scale of a modern steel plant or a sprawling smart agriculture setup. VFDs are basically the silent conductors running these massive operations. They run pumps, fans, compressors, massive factory conveyors, and even the elevators we ride every single day. For simpler stuff like running a basic fan, they might use standard V/F control. But for high-precision, heavy-duty jobs, like crushing rocks in a cement plant, they use advanced vector control to perfectly manage the motor's torque. They are everywhere.
So, the crucial point here is exactly why plant managers and, let's be honest, accountants absolutely love VFDs. Because you only use the exact amount of energy required for the job, you get major energy savings and much lower power bills. Plus, that soft start and soft stop capability means vastly improved process control, a significantly longer life for the motor itself, and way reduced maintenance costs. It just makes the whole manufacturing process better, plain and simple.
Moving right along to Section 5, Safety and Troubleshooting Tips.
Now, even the best systems have hiccups. When things go wrong, the VFD's keypad display is your absolute best friend. It flashes fault codes so technicians can diagnose issues fast. Take an overvoltage fault, for example. You might actually just need to check your deceleration time. If you try to stop a massive spinning load way too quickly, it physically acts as a generator and shoots power right back into the VFD. Crazy, right? An overcurrent usually points to a motor overload or short circuit. Over temperature, definitely go inspect those vital cooling fans we mentioned earlier. And a phase loss almost always means checking your input and output wiring connections.
But hey, troubleshooting is one thing. Preventing the faults in the first place is the real goal. Safety is absolutely paramount here. You have to ensure proper earthing. You must use shielded cables of the correct sizes. Maintaining cooling requirements is non-negotiable. And here's a big one. Because VFDs switch high voltages incredibly fast, they create electromagnetic interference, or EMI. That's essentially electrical noise that can completely mess up other computers on the factory floor. So implementing proper EMI protection is a critical safety rule, along with your regular maintenance.
Finally, let's look ahead to Section 6, the future of automation. Now, what's really interesting here is how VFDs are evolving. They aren't just standalone boxes anymore. They're becoming highly interconnected smart nodes. We're talking next-gen integration with PLCs, the robotic brains of the factory, and SCADA networks for plant-wide control. By tapping into the industrial Internet of Things and AI, these drives are unlocking cloud monitoring and predictive maintenance. Imagine this. The AI analyzes the VFD's voltage data and tells you a motor bearing is going to fail 3 weeks before it actually breaks. That is a real game changer for smart manufacturing ecosystems. And as the saying goes, smart technology, powerful solutions, better tomorrow. Building this future requires real expertise, partnering with people who understand both the heavy physical hardware and the cutting-edge digital intelligence behind it.
And this is exactly where experts like DEVI Automation Solutions come into play, as highlighted in today's source material. They're providing those complete end-to-end solutions in industrial automation we've been talking about. Whether it's integrating VFDs, PLC programming, or deploying AI for everything from upgrading massive manufacturing plants to pioneering smart agriculture, they are bridging that critical gap between physical hardware and the Internet of Things.
So I want to leave you with this final, thought-provoking question to wrap up this explainer. With AI and the industrial Internet of Things rapidly advancing, how will mastering foundational technologies like the VFD empower you to shape the automated, energy-efficient world of tomorrow? Seriously, understanding the VFD is understanding the very heartbeat of modern industry. Keep learning, keep questioning, and thanks so much for joining us on this explainer.